Salam and welcome everyone. So today we're going to be working on the question on the screen that says use the van der Waals parameters for hydrogen sulfide in the resource section to calculate approximate values of one the Boyle's temperature of H2S from the formula TB equals A over RB, where TB stands as the Boyle temperature, A as well as B are van der Waals parameters, and R is the gas constant. And then we have a second question where we're asked to calculate the radius of an H2S molecule regarded as a sphere. So to start this, rereading the question, we're told to use the van der Waals parameters of hydrogen sulfide in the resource section of the textbook. So the textbook I'm using is the Atkins Physical Chemistry 11th edition textbook. And in the resource section of the textbook, we have the value for A. So the van der Waals parameters that involves attractive forces. It is 4.8, sorry, it is 4.484 atmosphere, okay, dm6 per mole squared. That's the value. And then the value for B, the van der Waals parameters that involves volume, is just simply 4.34 times 10 to the power of negative 2 dm cubed per mole. So these are the values. So from these values, we're asked to calculate the approximate values of the Boyle's temperature. We know the Boyle's temperature formula to be what they've given us, which is just simply TB, okay, equals A over RB. So what we just have to simply do is to substitute. So we know the value for A. So we have 4 point, you know why I keep saying 4.84. So we have 4.484, okay, atmosphere dm6 per mole squared, okay? And then we've got R, which we're going to be using 0.08206 dm cube atmosphere per mole Kelvin. Now, I want to quickly mention something. We know we have two different gas constants. We have the 8.3145 with the units, and we have the 0.08206. The 0.08206 is used here because the unit matches the unit of this gas constant 0.08206 matches the van der Waals parameters. If we had the questions that involve joule, then we're going to use 8.3145 joule per mole Kelvin because the unit would match the question that we're given. So that's just the reason why. So that would be times the value for B, which is just 4.34 times 10 to the power of negative 2 dm cube per mole. So that's it. So of course, we're going to cancel out the units. We're going to cancel out atmosphere, cancel out mole, cancel out 1 mole from the mole squared, and then cancel out the second mole and cancel out the squared. And then, of course, you cancel out dm cube. If you go into dm cube in dm6, is just going to have dm cube left. And then the other dm cube cancel out the other dm cube. So what we have is just Kelvin, which makes sense because we're solving for the Boyle's temperature. So we have all of that information down. So we're just going to rewrite what we have. So TB, okay, equals 4.8. Sorry, I don't know why I keep saying 4.8. I don't know what's wrong with my brain. 4.484, okay, divided by 0.08206, okay, times 4.34 times 10 to the power of negative 2. And then you have kelvins here. So that is how it's done. Kelvin, of course, the units for temperature. So now you just have to input all of this information in our calculator. So when we input this information in our calculator, we get the Boyle's temperature to be 12.59054 times 10 to the power of 2 kelvins. Of course, rewriting this temperature, the Boyle's temperature will be approximately 12.6 times 10 to the power of 2 Kelvin. So this is basically the answer to this question right here. The answer is this 12.6 times 10 to the power of 2 kelvins. Yep, that's the Boyle's temperature. So remember, the reason why I have approximated to 3 sig figs is because in chemistry, you have to look at the value with the lowest number of sig figs and use that sig figs as the number of sig figs for the final answer. So we have this A value to be in 4 sig figs. We have gas constant, it's a constant, so we're not really focused on that. And then we have the B value to be in 3 sig figs. So hence why I put this second answer, sorry, why we put the final answer in 3 sig figs. So that would be 12.6 times 10 to the power of 2 kelvins. Now we're not done. The second question asks us to find the radius of H2S molecule regarded as a sphere. So solving the next question, let me use the red marker. We're asked to find the radius of H2S molecule. Now it's important for you to know when you're dealing with van der Waals gas that the formula for finding radius regarded as a sphere is B approximate equals 4 times the volume of the molecule, okay, times Na, where Na is the Avogadro's constant 6.022 times 10 to the power 23 per mole. Okay, we have the volume of the molecule. In this case, the volume that we're dealing with is, in this case, the shape of the molecule is a sphere. Remember, they said the radius of an H2S molecule regarded as a sphere. So we're going to be using the volume of a sphere. So the volume of the molecule is going to simply be 4 over 3 pi r cubed. And then the b value is what we already have, which is just the 4.34 times 10 to the power negative 2 dm cube per mole. So we have that as well. So we have 4.34 times 10 to the power negative 2 dm cube per mole. Now, I want to quickly mention something. You're going to be wondering in this question that, okay, what is going on here? Why is it that we have this value? Why is it that we have this formula? It's important for you to know that in the Atkins Critical Chemistry textbook, this formula was actually derived. And I hope in a future video to derive this particular formula so that it's not going to be confusing for anyone and everyone can actually like answer questions. So right now, all you have to do is just memorize the formula. But just know if you have the Atkins Critical Chemistry textbook, it was explained in the textbook how you would derive this formula. But for right now, just know and memorize this formula for the questions that you're working on. So I'm glad that is over. So we're just going to substitute and reuse the formula in order for us to like solve the problem. So you have B changing to purple now. So you have 4, the volume of the molecule, you substitute. So that'll be 4 over 3 pi r cubed. Okay. So, and then Na, which is just the molecule. So you have B this. So 4 times 4 is 16. So you have 16 over 3 pi r cube Na. So the next thing you have to do is for you to rewrite this formula, okay, in terms of what we're solving for. So in this case, I'm going to rewrite this formula in terms of R. So when we do that, I'm not going to write the breakdown of how we did it because you guys are taking physical chemistry. So you're, at this point, you're supposed to be able to know how to do it. So you have 3 equals. We're going to, again, solve this in terms of, what do you call it? Write this in terms of R. So, of course, you cross multiply to do that. So we have 3b, okay? Sorry, let me go back to purple. So you have 3b, okay, when you cross multiply over 16 pi Na. That is how you have the R in the major position of it being alone. So the subject of formula is what I meant by major position. So of course, let's not forget that we have R cube here. So we're going to put out the cube here and say the cube root. And this is the new equation. So all we have to do from here is just to simply substitute. So R is now going to be the cube root, okay, 3 times b, so that'll be 3 times 4.34 times 10 to the power negative 2 dm cube per mole, okay, divided by 16 times pi, which is just the value for pi. We know that is 3.142, but I'm going to be using 3.1416, okay, times the Avogadro's constant, which we know to be 6.022 times 10 to the power of 23 per mole. Of course, yeah, so that's how this is done. So let me drag this out a little bit more. So when you have this, of course, we do what we do in math. We cancel out the units to make our work much more easy. And after we've done that, all we have to do is just work on it step by step. So we're going to focus on the numerator first. We have 3 times 4.34 times 10 to the power negative 2 dm cube. When you multiply that, you end up with 0.1302 dm cube. And then we also multiply the values in the denominator. We have 16 times 3.146 times 6.022 times 10 to the power 23. We end up with 302.699 times 10 to the power of 23. So next we have the cube root of what is the division of what is inside the cube root. So when we do that, we end up with 4.2972. So 4.2972 times 10 to the power negative 27 dm cubed. So when you cube root this value, you have R. There's no longer space. Anyways, we have R is now going to equal 1.6258 times 10 to the power of negative 9 decimeter. Of course, we have decimeter, no longer decimeter cube because we've gotten the cube root. So we've the cubed root of decimeter cube just becomes decimeter. So rewriting this, let's not forget that in chemistry, you're supposed to put your answer in the lowest number of sig figs. And we see the lowest number of sig figs we have here is 3 sig figs because it comes from B, which is 4.34 times 10 by negative 2. So we have to put our answer in that. So having our answer, we have R, okay, equals 1.63 times 10 raised to the power of negative 9 decimeter. So this is basically the answer to this question. For those of you who are watching this video, just know that there's another question that I have solved that is very, very similar to this, but the values are different. The molecule is different. So make sure you watch that video. It's going to be linked in the description. I also wanted to mention that if you have any questions, please put in the comment section. If you're a student who's struggling in any of your STEM related courses, whether you're in middle school, high school, or college, make sure you email me at shahabitutoring@gmail.com for tutoring and mentorship services. I help students succeed in all their STEM related courses throughout their academic career. So if you have any questions, again, put in the comment section. I wish you guys all the very best. Assalamu alaikum wa rahmatullahi wa barakatuh.